go to EMU.
Right, look at it.
It's 61%.
He still takes 2 years to talk about it.
And I have
You guys truly.
All right, let's go.
He's great.
Let's go.
You can't even see a woman that long.
We left off.
They already have. They were bonnets.
We left off on our focus. Oh, let's focus. We're on our focus review, and we left off ready for problem number 10.
Let's have
So,
Brady, some of us don't even learn. Yeah, Brady, some of us aren't committed.
So here is the deal. When we are solving graphically, there really isn't much for me to look at, right? I mean, you have your calculator, you'll be typing it in. So I am asking you to tell me how your window is set up. And there are lots of fine answers to this. There isn't like a single answer. But then, what do you see when you go to solve this thing? What are you looking at to get your answers? So, let's go ahead. It says solve graphically, so we're going to go ahead and type it in our calculator. So we'll go to y equals x cubed plus 4x squared minus 6x plus 1. I'm going to go ahead and zoom 6 to get me started. And I'm just going to hit graph and see what it looks like. So what I see is this. I don't know what you see, but that's what I see when I entered my equation, hopefully correctly, and zoom 6. How does that work? Is that what you got? Now, what am I looking for? It says solve. I am looking, oh, by the way, my window is negative 10 to 10 for x and y as I zoom 6. And that's what will come out every time. You can adjust that. Kids, I don't care what your window is. I want you to see 3 points of intersection. So as long as you are seeing that, then this doesn't matter, whatever numbers you're using. And then how do we find those points? Second trace 0. And we'll set our left bound over here somewhere. Our right bound up here somewhere. And I got, for my first answer, negative 5.193. What you got? And then I look at these two now. Gotta be real careful. Right bound's over here, left bound has to be down here for that one. Because you gotta keep these separate. So right bound, left bound for that one. So 7 count 0. Okay, how are we doing? Are we getting those numbers? You okay with that? Now the next one is the same thing, except it's an inequality. So I'm going to do the same thing. Right now, I'm going to leave my window just like it was. And I'm going to see what I look like. make an adjustment, I'm gonna wait and see. Okay. Oh, that gives me a good picture. I see something. It looks like this. Now, what makes this one different? You know what makes it different.
Two.
Well, there's only 2 points, first of all, okay, so that's one difference. Negative 1.14, okay. And 6. Now, what the other big difference is, other than the fact that we only have 2 points this time, is that it's an inequality. So we aren't going to answer like this. Where is that curve bigger than 0 or equal to? Wouldn't that be all of this and all of this? So our answer will be an interval. Okay, so everything's the same about these 2 problems, except since that's an inequality, the answer is going to be a set of numbers, not just Boolean numbers. Good? All right, number 12. My projectile motion formula is written there on the paper. Your general formula. So if I gave that to you on the review sheet, guess what? Not the test, right? But it's very just like this, you gotta plug the numbers in. So here we go. Negative 16t squared plus what? 38t plus 10, my initial length. So part A says write the equation for this problem. So there it is, there's the equation for this problem. Okay? Now, I'm just gonna go ahead and graph that on my calculator before I start answering questions. Just kinda wanna know what it looks like. So you're using X's, these are X's. And it's kind of squished up, but it looks like this sort of. And that makes sense to me because I am throwing a ball, here's 10 feet up. I'm throwing a ball up into the air, and it's gonna go up and eventually come back down and hit the ground. Would you agree with me? So let's see what the questions are. What is the height of the ball after 1/2 second? One option is to put 1/2 in for the t's. Another option is, I can't remember if we talked about this, if you go to second trace again, the very first option is value, and then type in 1/2 or 0.5. It will tell you that it's 25 feet above the ground. So it's perfectly okay if you want to plug in 1/2, you will get the same answer. But your calculator will let you plug things in as long as you have the equation already in there. So the equation has to be in there, y equals, and then you can ask it for 1/2. All right, is that all right with everyone? Alright, next question, when is the ball on the ground? So here we go, second, out 0. When am I on the ground? I got 2.614 seconds. No? I think that's right. Anybody else get 2.614?
Yeah.
When is the ball higher than 12 feet? So here's 12 feet. Here's 12 feet. I want the ball to be higher than 12. So won't it be this whole part right here?
Yeah.
So I'm gonna find out where it equals 12. So you'll do this however you want, but I'm gonna put in a second equation. I have this already in. Now I'm gonna put y2 is 12. Don't see it, so I'm gonna have to increase my window, yeah. Now I see it. So here we go, second calc intersect. 0.354. Two point three two one. So second calc, I used intersect because I put this in as a separate equation. So where is it higher than 12 feet? Between 0.054 and 2.321. Okay? Now if we go back over to the front side, there's one more problem. I squeezed it on there sideways, number 11. So using the data, from 1999, so 1999, comma 53.2, and 2002, write a linear equation for this data. You know how to do this, Michael.
Slope.
Yeah, we're gonna find slope. So 55.1 minus 53.2. How do we calculate slope? Y over X. Huge pet peeve, kids who do it upside down. Don't do it upside down, I will embarrass you. Y over X. Alright, so what do we get? I got 19 over 30. I'd rather not round off. So when I calculated this on my calculator, I got 0.63333. So I just math fracked it. Remember how to do that? You just hit your math button and then enter. It will give you the fraction. All right, now what? I got my fraction. Now what do I do?
One slope.
y minus 55.1 equals 19/30 times x minus 2002. Now that is
It's forward.
perfectly okay. Perfectly okay. Or we could distribute, which is happy, and add the 55.1 over. But regardless, we're okay to do it that way. But the next question says, find the imports in 2020.
Would that not be 1.9 instead of 19?
I get 55.1 minus
Change it to
53.2.
30 instead of 3.
And then, so that subtraction is 1.9, and this subtraction is
They did that.
3, but we're not allowed to have fractions and decimals
Oh.
inside each other. So if I times by 10, I would get 19/30,
Gotcha.
which is what my calculator would give me when I math right. Okay. Now, what was I saying? I'm going to put 2020 right here. And then let my calculator just do some work. So 19/30 times 18, adding 55.1. I got 66.5 billion. Now, we will look at the other review sheet if you wish, but are there any questions you have about homework I turned back or something? Anything that's keeping you awake at night regarding mathematics?
Can we go over finding the center and radius?
Finding the center and radius. So if I look on the, like, first page review here, number 4 talks about circles, so let's do that. And then we'll get from another perspective too. So I got a center at 4,1 and a radius of √6. Well, that is the best case scenario because I have what I need. So x minus 4 squared, y minus 1 squared equals 6. This number is r squared. So Erica, it's important that we know what the equation of a circle looks like. This is what it looks like. Center is at 4,1, radius 6. Okay, now, yeah. So the second question for B, this was A. For B says, I'm gonna do the same thing, but this time, all I have given to me is this. In order to write the equation, I need to know the center and the radius. So, how would I find the center and the radius? Midpoint will be the center, right? This is a diameter. So midpoint would be the center. How do we find midpoint? Add them and divide by 2, so we average them. So our center will be 2 plus 4 over 2, and negative 2 plus 6 over 2. So our center is 3, 2.
Sounds right to me.
You're confusing me, is that okay? So I know, so Eric, are you still with me? Center? So I know my equation is gonna be x minus 3 squared, y minus 2 squared. I just have to figure out what it equals. I know it's gonna equal r squared. I just need to find the radius.
Do I see it?
And that will be right here. So how will I find my radius? Distance, so 4 minus 3, 6 minus 2. Looks like root 17.
Sure does.
So in my equation, I'll put a 17 because it's r squared. Now, does that answer your question?
So for the radius, you're just plugging in the other points into the.
Distance formula from center to end point. That would be the radius. All right, anybody else have questions from homework or just something else in general? All right, well, take a look at this chapter P review. I just did number 4, but look down through the sheet, it's got 2 sides. Look down through the sheet, and what do we need to practice? All the
Go over like the properties again, like
So we're gonna go through those properties, okay? And remember, in Canvas, there is an extra property practice sheet. They're supposed to be, I'll double check that. But let's do these. Here we go. 1A. What property is that? Additive inverse. How do I know it's an inverse? They cancel each other out. When your things cancel each other out, it's an inverse. And this one is an addition inverse. All right, how about B? Commutative of addition. Boys and girls, when you commute, you go from point A to point B, right? You move. When things move, letters or numbers move, it's commutative. In this case, of addition. How about C?
Identity?
That's not an identity. I get what you're saying, but the identities, remember, 2 plus 0 equals 2, that's the additive identity. 2 times 1 equals 2, that's the multiplicative identity. 2 equals 2 is the reflexive property. The reflexive property.
Got me.
How about D? I know what you're thinking.
That's,
If I were you, I'd be thinking commutative,
it's reflexive.
but not reflexive.
How is that not?
It's reflexive's brother. It's symmetric. Symmetric. So here is the difference. If we had 2 plus 3 equals 3 plus 2, that is commutative of addition. But if 2 equals x, then x equals 2, that is symmetric. Why is that? Well, both of them involve switches. But here, the switch is across a plus. Commutative is a plus or a times. Here, the switch is across and equals. So that is a property of equality. That is symmetric. And how about E?
Associative?
I heard associative, but it's not associative. because associative means we have regrouped. And on both sides of the equation, what's grouped together? The 3 and 4. So the parentheses haven't changed. What has changed is addition. So it's commutative of addition. Commutative of addition. All right, let me put a couple more up here for practice. So I'll put 5 or 6 up here. I want you all of you try and figure out what they are, and then we'll see how many of you got right. All right, so here we go.
What was the number last year? Yeah, I know.
That one, you want to forward, so you will never be revised until the president has changed. That number will
You're supposed to be ready.
You're the last one. You're the last one.
Oh, I already wrote the problem.
It's never taken higher than 2 right now. Yeah, it's everything right off your back of the addition.
Yes. Take a minute, write down these properties, and we're gonna go over them. Hopefully you're 6 out of 6.
Lottie. This kid's serving our country. This kid is serving our country.
What's number 1? Distributive. Distributive. How about number 2? It's symmetric and reflexive older cousin.
Oh, that's a good
Transitive. This is a transitive.
Lottie.
So, remember, reflexive says A equals A. Symmetric says if A equals B, then B equals A. Transitive says if A equals B and B equals C, then A equals C. So back when I used to teach geometry a long time ago, and of course we talk about these in geometry, to help the kids remember, we got reflexive, symmetric, and transitive, alphabetical order, 1 letter, 2 letters, 3 letters. So that's how we can help us remember.
RST 1, 2, 3.
All right, what property is this one?
Inverse.
Multiplicative.
Inverse.
Oh, then, I'm doing this for you and you're even.
Come on, Autumn. Come on, Autumn.
That's
Oh, say Jimmy, shut up.
Yeah.
Ooh.
That's not
All
true.
right,
Yeah.
This is multiplicative inverse. What's this one?
Associative.
Associative
right.
of addition.
Here.
Here, nothing changed except the
That's addition.
grouping.
Oh.
That's associative of addition. What's this one?
Identity.
Identity.
Multiplicative identity. Remember, you can't abbreviate. How about this one?
That's additive inverse. Or no, sorry. Additive addition. Jeez. Notice how I'm the only one brave enough to actually speak up and they're making fun of me. You notice that? Everybody's laughing at my answers.
Well, your first answer was
Yeah, it was silly. It was silly. It was a silly. Yeah.
all right. Who else? Yep.
Can we go over
Can you find a problem on the sheet like you're talking about?
Go Dutchman.
Like down,
Brady's like a solid quadratic.
like C or D.
I'm confused with the, when there's a whole number in front of the X cubed, so A, and it can't be divided equally.
Okay, well, okay, so, yes, so I'll just write one down. And then tell me what's confusing about it, cause, first of all, Sydney, if you're doing the quadratic formula, so let's say we have 3x squared plus 5x
Yeah.
minus 2, right? If I'm doing the quadratic formula, then I don't care what the numbers are, it doesn't matter. I'll just leave this exactly like it is, A, B, C, okay? So in the quadratic formula, A can be anything except 0, it can't be 0. A can be anything, B can be anything, C can be anything. So if I'm going to solve this using the quadratic formula, then I'm just going to do negative C plus or minus the square root of the squared minus 4 times A times C all over 2A. And we'll work it out. Okay? Now, if I have to complete the square on it, then that cannot be a 3. So if I'm going to complete the square on it, step 1 is going to be to divide everything by 3. And so my equation would be x squared plus 5/3 x. I'm going to go ahead and say equals 2/3. I'm going to move this to the other side. And now I have to figure out what to add to both sides. So to figure that out is very easy. You don't have to do it in your head. You're going to take half of that. So half of 5/3 is 5/6. And then you gotta square it, so that will be 25/36. Okay, don't make it harder than it, just write it down. You can just, you're gonna multiply that by a half and square it. Then this will always be a perfect square. In this case, it will be x plus whatever you got to get that squared. So that would be 5/6. And then over here, I'm gonna get a common denominator. So I have to multiply this by 12. Oh my gosh. Did I get 49/36? I did. Which isn't what usually happens, but then I'm gonna square root. So x plus 5/6 equals plus or minus 7/6. So then I do negative 5/6 plus 7/6, which is 2/6. So one of my answers is 1/3. Then I do minus, so that would be negative 12/6, negative 2. Now that tells me, I never finished this, I didn't set this up, but that problem actually factors, so I could have done it by factoring too. But does that take care of your question? Is that the question? Okay. All right, who else? Something on the sheet, both sides, or something in your head?
Reader 8.
8?
Yeah.
8. So this is another equation like we did before. This is an equation So I'm just gonna set my calculator up. And I'm gonna start out with -10 to 10. And adjust that as I need to. Let's see if I see a picture here. I'm just gonna type that in on my calculator, so y equals, clear out everything else. Oh yeah, I got a beautiful picture. It's coming up from the bottom. What's that? Okay, did you get something that looks like that? Annalise?
Yeah.
Okay. So, remember now I'm solving. I didn't write the problem down, but where does it equal 0? So I am looking for these 3 points. So I'm gonna have to second calc 0, left bound, right bound, guess, 3 times. 1, 2. You know, let's do 1, make sure you know how to do that. We'll do the first one. Oh, I actually got -2 for the first one, did you?
Yeah.
So when you write your answer, it's just gonna be x equals -2. X equals that number, x equals that number. No intervals, because this isn't less than or greater than. All right, what else? .268.
Yeah.
Oh.
And then,
Oh, yeah.
point,
Otherwise,
732.
Okay, I'll take your word for it. I think you. All right, who else has a question about something? Number 5? All right, let's look at number 5. Which one is 5?
Say you remember how to do something.
Okay, so I'm doing 5A. Now, 5A, oh, all of them 5. All of them 5. Solve, no calculator. So, including the quadratics, like C and D, we're solving no calculator. We could use the quadratic formula, we could complete the square, we could factor, right? So there are no directions to tell you what you have to do. You just have to get an answer without copying off your neighbor. So, how I will do this problem is I will draw a number line and put 2 right in the middle of it. And then I will count each direction 6. Because this says the distance between my number and 2 is 6. So 2 plus 6 would put this boundary at 8, and this boundary at -4. Since these are the points where the distance is exactly 6. From here to here is 6. If I'm gonna be more than 6, then I need to be out here or back here.
Yeah.
So my answer is -infinity, -4, or 8 for infinity.
You know, that's the thing where like, you put in a number higher than like what is in this, either.
You can
this
always
or
do
this.
that.
Okay.
You always do that. If I have more than 2 dots, I'm going to do that. But if I have 2 dots, it's always gonna be between or out. But if you have 3 dots, yeah, you need to figure it out. Yeah. Okay, Mike?
Yep.
All right, Erica's got her hand up and I'll come back back to you, Erica.
Oh, better be an emergency.
Better be an emergency, exactly right.
I just listened.
Better be an
When's
emergency.
Going to bed.
What's
Because we don't use the bathroom in math class.
Can we do a harder solve no
It's
council?
too important.
What one do you?
Alright.
Like E, yeah.
E,
Yeah, 5.
problem E.
Go back in the old time.
Now, this is a no calculator. So, and there's no formula for this because it's not x squared, right? So,
GCF.
well,
Gotta split it.
GCF would be great, but I don't have one. So I'll split it, and then I do have a GCF. If I look at only the first two, so x squared, x minus 1.
The parentheses.
Distribute.
GCF here would be -4, x minus 1, because I took out a -4. Luckily, these match. Don't square it, just write it down. And then I have x squared minus 4.
It's gonna be 2.
Factors, plus 2 minus 2.
This whole chapter is for.
So what are the answers?
Negative 1, 2, plus or minus 2.
So this is the problem, Eli, that if this had been a greater than, let's say, then you'd still do all this, because this is where your dots are.
Could we do that just in
Yeah. So then I have to figure out how I'm going to shade. Okay? So to figure out how I'm gonna shade, I need to pick a section somewhere. I usually just like to start out here, doesn't matter. But if I put 3 in, my problem, you can put it in up here, or you can put it in, I like to put it in factors. So 3 minus 1 gives me 2, that's a positive number. 3 plus 2 gives me 5. 3 minus 2 gives me 1. If I multiply 2 times 5 times 1, am I bigger than 0? Yep. That means this section is shaded. No, we could continue that, but we don't need to, because we talked about every other section shades. So that one does, doesn't, does,
How would we write that out?
-2 to -1, or 2, 2, and 3. Those are infinite.
Why'd you pick those 3 numbers to do the multiplication, see if it was greater than 0?
What 3 numbers?
2, 5, 1.
You plug in the
I plugged in 3. A number bigger than 2.
Any 3 numbers bigger, or any 2 numbers?
Any, pick a number bigger than 2.
So she chose 3.
So if I put 3 in, 3 minus 1 is 2, 3 plus 2 is 5, 3 minus 2 is 1. Alright, another one, anybody else? Good questions here. $19,000, we're not gonna look at each other, we're gonna do math, Finn.
We do number 7.
7. Mr. Noel. Bought a new bicycle 5 years ago that cost $237. The bike is now worth $92. My equation y equals mx plus b basically. Models value of the bike as a function of time t. How many years ago was the value of the bike? 50, All right, let's keep in mind that this is linear. So this is the same as y equals mx plus b. Think about, how do you write equations of lines? What do we need to know to write the equation of a line? We need to know the slope, and we need to know some kind of point. Can be y intercept with some kind of point. So in order to find slope, I need a couple of points. So I'm gonna look at my data and my problem and see if I can come up with a couple of points. Here is my suggestion for the points. Now remember, my X is time and my Y is money value. Do those 2 points make sense to you? Yes, because at the beginning, when he walked in and bought the bike at the store, it was $237. After 5 years, it's down to $92. If these are my points, then I can find my slope. 237 minus 92 over 0 minus 5. That's going to be a negative number. Does that make sense, that would be negative? Yeah, because every year the value of the bike goes down. So Y equals negative 29x plus 237. Oh, Mrs. Ford, how did you do that? Well, what's it mean to be a y-intercept? Isn't a y-intercept where I cross the y-axis? And isn't that it right there? So here's the equation of my line. You could also, once you get your slope, you can do point slope and come up with the equation too. And then I want to know, when will the value be 150? So what would I do? 150 in here. And solve. Oh, I didn't have to round, I got 3. 3 years. Oh, this is a trick question. Really tricky. I would never trick you like this on the test, because this is tricky. So what does that 3 represent? That would be the ordered pair 3, 150, right? So if it's 3 after 3 years, how many years ago was that? 2 years ago. That's tricky. When I wrote this, I must have been mad at somebody. Okay? All right, tomorrow's test day. And you should have a charge calculator. So if you want to put yours over there to charge, you can. When you're in the morning to charge, whatever. At this moment in time, I should be here in the morning. Sometimes we have these surprise meetings. But I think I'm good tomorrow.